Alright, so let's say you're given this equation and the question wants you to compute the integral. So we must first establish the power rule. The power rule for any real number n not equal to -1 is given by this equation here, where x is our variable of interest, n is our power, and c is a constant of integration, just some random number. Note, this is the opposite to the differentiation power rule, which is given here below. If we compare these two, for the integral we add 1 instead of subtract 1, and in the integral we multiply by the inverse n plus 1 instead of just n. And this makes sense because the integral and the derivative, they're the opposite operation to one another. So we can apply this to our example, which is given here. Apply our equation. We can first break down this integral into 3, distribute the dx into each term. Number these terms and start with the first term here. Take out the constant, and we apply our equation, noting that n equals 4. We do some simple additions and get this for the integral, so we plug that in. 5 and 5 cancel, so we get this for the answer. Note, do not forget the constant of integration, so we get to add plus c. For the second term, we can take the constant out again, apply our equation, knowing that x is the same as x equals 1, so n equals 1 in this situation, so plug that in. Get this expression here, plug this back into our equation on the left, do some simple cancellations, and when we multiply the 2 back in, 2c can be simplified to just c because c is just the constant of integration and can be left as is. You can just ignore the 2 since this value can be really any random number. For the third one, we just have the integral of 1 dx, which is the same as x equals 0. So n is going to be equal to 0 in this situation. Apply this to our equation. Here we get 1 over 0 plus 1, x is 0 plus 1c. We can do some simple additions and then simplify and we get this. So then we can add our integrals for the first, second, and third term. We can note that c plus c plus c is just going to be equal to c because c is just a random number. So we can just generalize it to one value for the constant of integration. So this is our final answer for the integral of the function here. And we can check if this is right by taking the derivative of our answer. So the derivative should be equal to the original equation. This is an easy way to check if you got the right answer since the derivative and the integral are opposite operations.